In this week's episode of the AWS Developers Podcast, we're talking about networkings and more specifically networkings for developers. Good morning and good afternoon. Thank you for downloading the AWS Developers Podcast. We are available in all good podcast applications, Spotify, YouTube, Apple Podcasts, Deezer, you name it. As I used to say, if it is a good podcast application, there is a good chance that the AWS Developers Podcast is in there. As I said in the introduction, we're going to talk about networking, something which is typically not on the radar for developers, with my guest today, Alex Widish, your principal network specialist, solution architect in the networking team at AWS. So you're one of the specialists of VPCs and all the service around VPC. Tell me maybe, so first, thank you for being there. And second, tell me maybe why developers should care about networking, or maybe we shouldn't.
Oh man, that is a very, very loaded question. So yes, I think that's a great starting point. Thank you for having me. Hi everyone, and thanks for joining us. I do watch your podcast with a lot of interest actually, because my world doesn't interact that much, or didn't used to actually interact that much with developers. So to your question about why should developers care about networking, or why they shouldn't. Um, it's very often that I talk to customers and to developer teams in customers of AWS, and we land on the conclusion that maybe developers shouldn't necessarily care about networking. But I would say that there are some things in networking that any good developer should be aware of at least. First, networking is the foundation for everything. It's
Mhm.
the thing that connects things together, right? It's the piping. And continuing the analogy with the piping, actually, you don't care about the piping that much, as long as it's working, right? And it does its job. When it doesn't work, as expected or as intended,
Then we
that's
need to go
when
to the plumbing.
exactly, exactly. And that's when you kind of start caring about things. Um, Same as with networking. I don't think many modern application developers these days understand in depth, for example, IP address routing, or what IPv6 is, or what routing protocols are. And I would argue that they shouldn't. However, when, for example, they're troubleshooting an application connectivity, right? And they're saying, oh, I can't connect to this endpoint, or my curl is failing.
And
That's
and that's
when,
the easy part when it's not working at all. That's the easy part to debug. When things are more subtle, like it's the latency increasing or the performance is not there, that's much more
exactly,
complicated. And this is where you need knowledge as well.
exactly, exactly. So things, as you gradually progress through being aware of the piping, I'd say, that's when you discover these interesting things such as latency and why latency is different between different applications depending on their deployment model. Um, there's a funny story that I usually tell folks who I talk to about networking, who are not networking specialists or sort of very networking focused folks, is that every time I get the question of why is latency so high between these two regions, or why am I seeing the latency increase if I'm going from this region to my data center? I always come back to physics and the speed of light.
And the speed of
And
light, yes.
yeah, exactly. And the fact that it's still there. We still need to take it into account. So um, I think that's probably the first thing that should take us to think and be aware of networking, and how networking works, and how infrastructure works, and why we can do some things with our applications, and why some things can't be done. Why latency cannot be sub-millisecond if we're going from East Coast to West Coast, right? Um, so yeah,
I,
that's probably the first.
I came from a world before the cloud. I have a couple of white hairs, so I can tell stories from the beginning of the century or even last century, where actually developers didn't care about networking, especially in large organizations. It was totally separated. The developers were in one building, the operational team, production team as we call them, were best case on a different floor, worst case in another building. I'm talking about large corporation, government organization, financial institution. And we didn't talk to each other. We just ship or package, zip, whatever, and they deploy and run it. And I don't have to care about all that. The cloud changed that in a way. Maybe the DevOps trend, where developers are also responsible for the operation of their solutions.
I think cloud did change that at the beginning, at least, when, for example, coming to AWS, you got all these tools that you could use to deploy your applications. You had VPC, right? And you're sort of getting into the gap between networking and the application got very, very small because it was part of the application deployment process to have your VPC, for example, right? Not even talking about EC2 Classic, which was before VPC. So you needed to know your IP addresses. You needed to know kind of where the lay of the land is in your cloud environment. So I think that to begin with kind of brought developers and networking folks together. However, I think old habits die hard. So I think even if at the beginning, maybe for small enterprises or small customers, this was an opportunity to bring developers and network teams together. I see a lot, even today, folks building or maintaining the gap between these two personas, maybe even unconsciously. As, for example, there's teams who are centrally managing networking in larger scale enterprises. They're building platform teams, which are like, okay, let's take VPC creation, VPC connectivity, all the stuff. There's a network team that does it, and then you as an app developer don't necessarily need to know about it. So creating this level of abstraction helps with agility, helps with saying, okay, you as a developer, you don't need to know that much about networking, but also creates this gap between the two personas. And it's fairly hard for both of them to understand what the other one means and what the requirements are, what the limitations are at each layer. There's a super classical thing of troubleshooting from a networking perspective where the network folks are always saying, go ahead, blame the network. It's a classical meme.
I blame the DNS. It's always the fault of the DNS.
or DNS. It's always like, this thing is not working. I don't understand why it's not working. It's definitely the network. So there's a support case open to the network. The network team is like, I don't know what you're trying to do. Like, just give me a source address and a destination IP address. And then developers are saying, well, I don't know my IP addresses. And here's where the friction between these two teams becomes increasingly sort of impacting agility, I would say, and the speed of deployment and speed of development and how innovation can happen faster.
It's interesting that you said that at the beginning the cloud had a tendency to flatten the network stack and to make the developer more aware of the networking, because as you said, we deploy an application, but we also create a VPC for that application. But then that tendency stopped a bit, especially for large enterprise, where the traditional roles emerge again in the cloud, where you have a team dedicated about the network and another team developing, and they deploy to a platform that has been created by someone else. And I talked recently with a very large customer called Engie, and I can mention them because they were in the podcast a few months ago, where they explained they transformed their global network, they moved that to AWS, and it's a separate team that manages the network in the cloud, while the development team is doing what what they can do is
Yeah.
to develop and to deploy application without having to care about the low level stuff. At the beginning, when I was a technical trainer at AWS, I teach my or customer and my students about VPC and the basics, and this is a NAT gateway, and this is an internet gateway, and this is a subnet, and these are the routing tables and NAT and blah blah blah.
Yeah.
The reality that works for small application or small company, but the reality for large companies like Engie that I mentioned, Engie has 700 AWS accounts, and of course, a workload cannot be self-contained in an account. Most of the time, they have to interact with services, database, data from other accounts. So this is where the complexity is coming from. It's the multi-account nature of the architecture from our customers.
Yeah, absolutely. And I think with multi-account and multi-region architectures too, because having workloads deployed across multiple regions is becoming slowly the norm in terms of our large and largest customers. I would say this is the thing that's driving or that's putting even more importance into how you do your network architecture and how do you plan connectivity for your applications that are now across thousands of accounts in a region or across maybe 15, 18 AWS regions. You mentioned Engie with their global WAN on AWS. We have a lot of customers that have built their global WAN on AWS using services like AWS Cloud WAN, which include 15 plus regions, right? They're these
Wow.
WANs. And imagine connecting thousands of accounts across 15 plus regions and trying to also make sense of that as a developer and as a network team who is sort of tasked or in charge of managing connectivity, ensuring that it's there, it meets the business needs of the application teams. Um, it ensures performance and their metrics, SLAs, SLOs, etc. So yeah, it becomes a pretty interesting and challenging task, I would say, to sort of bring these teams together and ensure that each and every one of them gets what they need out of the infrastructure, out of the account structure, out of the connectivity tools that they're using.
What are the basic building blocks in terms of connectivity that developers should know about? Maybe not be a master or an expert, but at least know they exist. And something I like to do when I have a multiple service in front of me is to try to put them in box. Okay, this is the purpose of this service is to do that. The purpose of that service is to do that. I know the reality it's a bit more complex because most of the services have a bit of overlap and they can be, but try to define the big categories of each of them. So if we move over the simple VPC subnet inside a single region, what are the services developers should care about, should know about, at least by name, uh, in terms of networking?
I would say that even before we get to services,
Mm-hmm.
I do like to sort of, I used to be a trainer as well, and I do like to create or help folks create their own mental maps around what is this connectivity thing supposed to be. I would say that to your point, you have the VPC and you have subnets and you have route tables. The purpose of these constructs are more or less to give you a place, your virtual network in the cloud, right, where you would deploy your applications, um, and to govern the flows for your application. So think about the route table as a set of rules that allows you to specify, configure, right, define um, what you want that workload that is deployed in a specific subnet or the set of workloads in a subnet to be able to communicate with, right? It's always about the destinations.
Mm-hmm.
Where can those workloads get to? And those destinations can be local within your VPC, maybe in a different subnet, right? And they are usually outside of your VPC. So funny story. We've thought about VPC as your bounded, secure, private network in the cloud. And
And
then
the
we
first thing
started
customer do is to try to make things communicate across VPCs now.
exactly. The first thing we do is poke holes in the VPC. And you have bigger holes or smaller holes. NAT gateway, for example, for private connectivity, private subnets out to the internet. The internet gateway. The internet gateway is actually a very big hole that you
Hmm.
can poke in your VPC. And there's ways to secure that and make sure that unwanted traffic is not allowed out or in to your VPC. Um, so those are connectivity options for getting out of your VPC. So think of that mental map that you create with your VPC, and then expanding your universe and saying, okay, where can I get to? So you can get to the internet, and most importantly, you can get to other applications that are deployed in other VPCs. So you get to that. How? That's the question. And you have quite a few options. You have
Yeah.
VPC peering.
Hmm. I
I
was about
think
to say unfortunately, but actually it's a strength and and it's
it's
not because yeah,
actually,
we have to figure out which one is the best for my
yeah,
use case, for my specific usage.
yeah. That is probably the most interesting part, and that's why you um, would probably need to have these two personas, network
Hmm.
and application persona,
To
talking
guide
more
you.
to each other,
Hmm.
because otherwise the network team might go and say, well, I'm just gonna select this one single connectivity option and it should work for everyone. But then in general, architectures work around the 80-20
Hmm.
percentage rule, where they need 80% of use cases, and there's 20% of use cases that are exceptions. If these two personas don't talk to each other, it's very hard to identify those exceptions. It's very hard to understand, well, does this network meet the needs of the developers of the applications that are deployed on top of it that communicate to each other? So yeah, another very good reason why developers should talk to network folks.
And why we need
Um,
solution architects. the,
yeah,
let's go back to your example. I like it. I have a VPC, which is my secure, my fault, where I have my microservice being deployed, but that microservice needs to talk to another service, and maybe another microservice or database that sits in another VPC owned by another part of the organization, maybe another account, and then maybe later in another regions. So let's go gradually. What are the
perfect.
options I have to make these two talk to each other?
You see, you've already expressed this need in terms of endpoints, right? You want to access this other application, you want to access this other database. You have not spoken in terms of you want these IPs to talk to these other IPs,
I'm a developer.
right?
I don't care about the IP. I want to talk to
Exactly.
the database.
Exactly. So, in terms of VPC connectivity options, if we are to, like we started with VPC peering, we have AWS Transit Gateway, we have Cloud WAN. Um, these are defined as VPC connectivity options, and they are what we call in the networking world layer three connectivity options or network level connectivity options, which essentially allow you to talk between IP addresses,
So
right? At
network
a
level 3, it's the IP part of the network.
exact,
It's one IP talking to another IP address. So routing a
exact,
packet from one IP to another, from one host to the other.
exactly. So that's what network people see. Network people see IPs, right? They're like, oh, can this IP talk to this other IP? And what helps network folks answer that question is looking into route tables, right? If in the route table I see a destination that includes that IP that needs to be reached, from my perspective,
Yeah,
they can talk to each other,
I know
right?
where to send the packet. It will go to that router, and
Exactly.
somewhere after it will reach the destination.
Exactly.
Or
So
not.
one super classical analogy of the network layer is that you can think of it as a mail delivery system, right? It knows the destinations, it knows the addresses. It gets, oh, it's actually like Amazon.
Sending parcel. This is what we can do at Amazon at
Exactly.
very large scale. We do the same with your IP packets.
Exactly. Exactly. See, that's a good one. So yeah, we don't care what's in the package, right? We like your Amazon driver doesn't really care. They take the package, they deliver it. You have Prime or you don't have Prime, that just defines the duration. Um,
I like the
so that's it.
analogy because there are big pipes like the planes moving things between fulfillment center and then smaller one down to the
Exactly.
electric van that will do the last mile delivery to your door. Yeah, it's a good
Exactly.
analogy.
Exactly. So yeah, from the Amazon delivery system perspective, what we know about is IP addresses, which is essentially your home address written on the parcel. Perfect. What you as a developer care about is what's actually inside that, right? What is at layer 7 of the stack at the application layer, right? You want to talk to a database on a specific port using a specific protocol, for example, TCP, right? TCP standing for Transport Control Protocol. Uh, from your perspective, you don't care about the address, right? You kind of take that as implicit and it's existing, right?
It's important.
Um,
This is how my packet arrive at home, but it's what I'm going to do with the inside of the packet at home.
yeah,
First, be sure it reach the good floor at home if there are multiple apartments, and then
yeah,
the specific usage.
yeah, exactly. One thing I said, transport control protocol, transmission control
Mm-hmm.
protocol. Sorry, that is
Oh,
TCP. Um, It also has UDP, user datagram protocol, its connectionless counterpart, just to make sure that everyone
for
here,
DNS, for example,
yes,
or old-fashioned DNS, because now DNS is over HTTP as well. But okay, that's another subject.
yeah, yeah. So that being said, um, I think this makes it fairly clear for developers what the network connectivity options are. Um, However, it doesn't make it easier, though. It doesn't, like, knowing about these things doesn't necessarily solve the problem of how do I get to that destination, right? What do I need to configure and why to be able to get there? In the context of me knowing that endpoint, knowing that destination, and knowing that I want to get there.
So back to my original questions: what are the different options there is or there are on AWS to bring connectivity between two VPC across multiple accounts or multiple regions? And what are the pros and cons and the challenge of each of them?
Well, so we said VPC peering, Transit Gateway, AWS Cloud One. All of these three you can use both intra-region, cross-region. They each come with considerations. So with VPC peering, for example, you have a limitation in terms of how many VPCs you can peer together. It is, however, a high throughput, low latency connectivity option.
Inside a single region or across multiple regions?
You can also
Or
use
both?
VPC peering across regions for sure. Um, you get some good sort of quirks of using VPC peering, but keep in mind it's not super scalable. Also, it does require you to have non-overlapping IP addresses. So here it is.
Which is
Um,
super complicated. It's easy when you start from scratch, but in reality, large companies have tons of ranges of IP addresses and different data center, and okay, yeah, they cannot guarantee that.
I would say it's even harder if you start the when you get an AWS account, you get that default VPC in
Mm-hmm.
each region. That default VPC has by default the same IP space in every single region. So you cannot peer them together. So you have to go back and have a thought of I should have non-overlapping IP space. If you're
That's
part of
doable
a
at scale. Do you see any customer really doing that at scale?
Yes, yes, but it takes a village, I would say.
Dedication.
Yes, takes dedication, takes a really good IP management tool.
Mm-hmm.
For example, Amazon VPC IPAM can help you with that. But you had to know what you're doing. You have to know that, hey, there's some IP addresses there that I need to control, and I need to make sure that they're not overlapping. Uh, in large scale enterprises, that probably already happens because you have a network team, and
Mhm.
that network team lends you the VPC with the IP addresses already configured. But if you're a startup, or if you're just like testing out and trying to make things work in your dev account, and you don't know about these things, you might get to a place where you're going to be blocked by the fact that you cannot peer VPCs together or connect them together.
So that's a VPC pairing or peering. What is the difference with Transit Gateway? I see Transit Gateway more like a hub and spoke type of configuration, like a central router or virtual router. Is it correct? Sorry, I'm using my developer vocabulary to describe them.
That's perfect. That's perfect.
Okay.
Yes, so Transit Gateway came in 2018 as a mechanism for us to provide AWS customers with more scalable VPC connectivity. And yes, it is like a hub and spoke type architecture where you can connect all your VPCs in a region to this transit gateway construct. It is a highly available, highly scalable construct across AWS availability zones in a region. So keep that in mind. It's not like just a router box.
It's a
Um,
virtual one across AZ, some
yes,
kind of magical stuff that sits across AZ, like a load
yes.
balancer in AWS.
Yep, it is. There's some cool components to how Transit Gateway scales and ensures reliability. So yeah, you would connect all your VPCs to the Transit Gateway. You will say in your VPC, well, anywhere I want to get to in my internal network, I'll just
Go
send
there.
traffic to the Transit
Mhm.
Gateway. And that makes things really easy
So it's like
because if
the
you
central post office, to go back to your analogy.
exactly,
Mhm.
exactly. It's like a central post office. You don't have to know the addresses of every single one of the destinations, right, that you can get to. You just have to know that, or actually, even better. Um, think of the fact that you have a letter and you want to post it, and you want that letter to get to the destination, right? You don't have to know the route to the destination. You
Just
can
the
just say,
mailbox close to me.
I'm just mailing it, and
Mhm.
I'll leave the post office routing, right, to take care of that for me. Otherwise, imagine that you would have to know every single address and every single street and every single destination, for example, in your neighborhood. You may know that, but the more you expand
Mhm.
your
Yeah, it's not
reachability scope,
scalable.
it's not scalable. Exactly.
And back to your non-overlapping IP range, can we have overlapping IP networks with Transit Gateway?
Oh man, that is
No,
a
probably
very
not.
good question. You can, but you have to go through some workarounds, not by default. So imagine that you have two VPCs connected to each other through the transit gateway. You can connect them to the transit gateway. Transit gateway accepts them. But from a true connectivity perspective, right? That flow cannot
Mhm.
just simply happen like that. Because imagine in one VPC you have an IP address, in the other VPC you have the
The
same
same,
IP
yeah.
address, right? So you have to have a translation mechanism.
A
And
NAT?
that's,
Oh.
yes,
Mhm.
NAT, exactly, network address translation. The AWS NAT gateway supports private NAT. So you would have this pretty complex architecture with private NATs and load balancers in a non-overlapping IP space that you have in each VPC, which adds quite a lot of operational complexity and cost.
But it allows customers to connect, like if they buy another company, and it allows to connect them together, maybe without doing a big deep networking rework before connecting the networks.
That's true. It's an option. It's an
Hmm.
option. I would say we probably have better
Better
options.
options, for example.
Yes. Um, do you know about Private Link? I think everyone knows
Private
about
link
Private Link
in
more or less.
my mental representation of all the tools. It's a way to connect from a VPC to an AWS service. For example, if I have a private VPC with just private IP address and my application wants to talk to S3, S3 is a public AWS services, so with only public endpoint, public IP address, so private link allows me to connect my private application to S3 without going through a public IP address and a NAT gateway.
Perfect.
Yeah, I passed my certification, my network certification.
Perfect. Well, after our episode today, everyone who has watched the episode should be able to pass the networking specialty cert. Without digressing, though, yes, private link started as the way in which applications in your VPC could connect to AWS managed services without having to have that NAT gateway and internet gateway, which we talked about. It's a pretty big call.
Cost effective, let's say. Super expensive.
Yes, you can draw private link endpoints for AWS services in your VPC, but you can also use private link to expose your own services, right? Your own service endpoints. And here's where we come back to what you were initially saying and what the developer mindset is, more than just, oh, IPs connecting to IPs, which is definitely not what developers are thinking about. Developers are more thinking about, how do I connect to that endpoint, right? That application that means an endpoint for me, right? And Private Link actually has its naming as Private Link Endpoint, right? Private Link Endpoint for AWS managed services and Private Link endpoints for your custom services, the services that you own, you manage in your environment, and you want to expose from your VPC, from where those are deployed, to other VPCs in a very service-oriented connectivity option, right? So you have an endpoint that you drop in the client VPC. Now, do you kind of foresee what the challenge is with this?
Every service I want to access to has to manage or to create its private endpoint. I need to collect them all to know their IP address or their DNS names. So that might become. I remember seeing the microservice architecture diagram of Amazon.com, which is like a cloud literally full of dots and links. At that scale, it's probably very hard to manage.
Yeah, exactly. So even if we don't talk about networking or endpoints or any of these concepts, in a large scale or as you're growing, you would end up having a lot of applications, right? Not even talking about VPCs and accounts, but just application endpoints to begin with. These application endpoints are most likely, hopefully, for everyone listening to us, identified through a domain name system, right? DNS. So they would have a DNS name. That's the most meaningful thing that you know about that endpoint, right? Once you have a lot of applications, right, you would have to have some source of truth of what all your services are, right? That's step number one. It's usually referred to as a service catalog or as a list of services that you have available. Now, the second part to that is understanding what are your service connectivity patterns. What should talk to what? What is allowed to talk to what? And usually we have customers describing this, I quote, as a big ball of wax because everything talks to everything. And
so many one-to-one connectivity there, trying to document that. And yeah, I imagine the people from compliance or conformity that scratch their head. Is this application authorized to talk to that one? Should it?
Yes, exactly. So as you bring scale to your environment, it's very important to start considering this. And this is actually nothing to do with networking or transit gateways or cloud WAN or anything like that. The advantage of these solutions is that they give you just blanket layer 3 connectivity. They don't care, again, what you're transporting there, but they also don't make it easy for you to understand what talks to what. They'll make it very easy for you to say, oh, this application should talk to this other application, but it shouldn't talk to the third application from a security perspective. They give you coarse grain, so broad segmentation options. For example, in AWS Cloud WAN, which is global connectivity on AWS, you can define segments, and these are global segments. You can name them, for example, production and development and QA, but these are pretty broad, right? They like everything in production
Hmm.
can by default talk to everything else in production.
Which is not the reality, or should not
So
be.
yeah, and that's where these additional considerations of, well, how do I secure these flows? How do I get visibility into the flows first and foremost before even thinking about securing them? Um, how do I monitor each of these flows? How do I understand that service one can talk to service two, or service two can talk to database three um, in a consistent manner? How do I understand if that's the intent or not behind the communication flows?
And I guess all customers have the same type of questions. And one thing we love to do at AWS is to remove the undifferentiated heavy lifting. So how can we help our customer to solve this type of connectivity problem at scale?
Well, that is where Amazon VPC Lattice comes into play, and what we've sort of cornered as application networking on AWS, as in its name, right? Kind of suggests that these two personas come together finally.
Application networking, okay?
Yes, yes, application networking. Um,
So the service name is AWS Lattice,
it's
Amazon
Amazon
Lattice,
VPC Lattice.
Amazon
Amazon
VPC
VPC
Lattice.
Lattice.
It's important to be
Yes.
precise on the service name. Just give us a glimpse, but don't say too much, because we are going to do a teaser for the next episode next week, where we are going to dive into that, into much more details.
Perfect. Okay, so a teaser on Amazon VPC Lattice. Well, if you followed us throughout this episode, you kind of understood a bit of the
The
challenges
challenges.
around developers and networking folks, and how do we secure things, and how do we get things to talk to each other. Well, that's exactly what Amazon VPC Lattice comes to solve for, and what application networking is intended to do, to help developers and to help network folks and to help security teams bring or come together, right, at the table and say, okay, how do we get this consistent experience across all the three personas? How do we all look at the same thing? How do we give developers the tools that they need? How do we give network folks the tools that they need? And how do we give security the tools that they need to deploy, manage, control their applications, control and manage connectivity, and enforce security policies? So I think that's kind of the big spectrum of bringing together these three personas. And I'm super excited about next week. I can't wait for us to talk more about Lattice. I am very
That's
tempted to give you more.
we are out of time. Thank you, Alex. No, thank you. You did a fantastic job to position the challenge that our customers have to deal at scale with connectivity for their application, endpoints, the security aspect, the connectivity aspect of it. You want to know more? Stay tuned. Download the episode from next week in the same podcast application. And next Friday, you will have the follow-up of this conversation with Alex, where after laying out all the challenges and explaining the complexity of large-scale application connectivity, we are going to show you one way to solve that with Amazon VPC Lattice.
Yes.
Yeah, got it right.
Lattice. We have an internal joke. It's a lot of folks name it lettuce. It's lattice. Please don't say lettuce. It is also not a service mesh. So I'm going to say that before our episode next week. We're going to talk a bit about service meshes and what they do, and about lattice and how it can help without the overhead of service meshes. So looking
Next
forward
week
to
in your
that.
podcast application, Alex Widish, your principal network specialist solution architect. Thank you for your very clear explanation and setting the ground for next week's episode about Amazon VPC and Lattice. See you in a week. Bye.